Yo, what's up everyone? Welcome to the 2016 USNCO local exam. Today we're going to be doing the descriptive / laboratory section, so that's questions 7 through 12. Alright, so let's start off at number 7. Dissolution of which salt in water results in a decrease in the temperature of the solution? If we're talking about decrease, then we're talking about something that is endothermic. The dissolution of salts, you can't usually tell whether or not it's going to be endothermic or exothermic, but the general rule is that if you have a salt of ammonium, if you have a salt of NH4+, those tend to be endothermic. And the only salt of ammonium that we have here is answer choice D. So our answer is answer choice D. Alright, let's go to question 8. What is observed when equal volumes of 0.1 molar aqueous hydrochloric acid and 0.01 molar aqueous Na2SO3 are mixed? Alright, so to see what happens, let's just write out the reaction that's happening. We know hydrochloric acid is reacting with Na2SO3. This is going to be a double displacement reaction, so the sodium is going to pair up with the chloride. We have NaCl, and then we're going to have the hydrogen pairing up with the SO3. So we're going to have H2SO3. Now, currently, both of our products are aqueous. This is also aqueous. But remember, H2SO3 was one of our intermediates. H2SO3 is a really weak acid, and it doesn't like being in this state. Instead, it wants to break down. So what happens is that it almost instantly breaks down into SO2 and H2O. SO2 is a gas and H2O is a liquid. So the final reaction produces a gas. Alright, let's look at the answer choices now. A colorless solution with a white precipitate. We don't have a precipitate here. We only have aqueous, gas, and liquid, so none of those are solids. Colored solution with a white precipitate. We don't have a precipitate. Colorless solution with a colored precipitate, no precipitate. So D, colorless solution, no precipitate, and a gas evolution. Remember, the gas evolution is the SO2 that we produce with the H2SO3. Okay, let's go on to question 9. Which combination of dilute aqueous reagents will not produce a precipitate? So we have 4 answer choices. Let's go through what each of them produce. So let's start with AgNO3 plus HCl. Remember, this is a double displacement reaction, so what we'll produce is HNO3 and AgCl, nitric acid and silver chloride. Now is when you have to know your, precipitation rules. So HNO3 is aqueous, and looking from your precipitation rules, silver chloride, is going to be a solid. So we do produce a precipitate with answer choice A. Alright, let's look at B. We have NaOH reacting with HClO4. Again, double displacement reaction, so we're going to produce H2O and NaClO4. Now, H2O is a liquid, and the NaClO4 is actually aqueous, and that's from your precipitation rules. All compounds with a sodium ion in it is soluble. So B does not produce a precipitate, so B can stay. Let's just go through C and D to make sure. So C is BaBr2 with Na2SO4. Now, what does this produce? Again, double displacement reaction, so we're going to produce NaBr with BaSO4. And there should be a 2 here to balance out the reaction. Alright, NaBr is going to be aqueous. That's going to be aqueous from your precipitation rules, but BaSO4 is actually going to be a solid. So we do produce a precipitate with C. Let's look at D. Which we have, I think you can't see it anymore, but it's zinc, Zni2 with KOH, double displacement reaction, so we have Ki with zinc hydroxide, and there should be a 2 here to balance out the reaction. Ki is going to be aqueous, but zinc hydroxide is actually a solid. So you do have a precipitate being produced in D as well. So the only answer that makes sense is answer choice B. All right, let's look at the next question. A solution of a salt of which metal produces a bright red color in a flame test? So this is just memorizing your flame test colors. Let's go through all your answer choices to see what kind of color that they produce. Lithium actually produces like this red color. So this, I guess, could be the answer. Sodium is this bright yellow, so that's not red. Potassium is purplish, and copper is going to be green. So sodium, potassium, copper don't make sense. It has to be lithium. Let's look at question 11. Which cation forms a colorless aqueous solution? So we have a bunch of cations here, and this is memorizing your the color of aqueous solutions when they have a transition metal in them. All right, so cobalt 2 plus is this pink color. Nickel is going to be greenish, green. I guess it doesn't really make sense to write all this in blue ink, but whatever. And copper 2 plus is going to be like this light blue. And zinc is colorless. So our answer here is or D, sorry. A lot of the times whenever you're asked for like looking at colorless aqueous solutions, it's usually going to be zinc for whatever reason. This test loves using zinc as its colorless transition metal. All right, let's look at the last one. Which 50 ml container would be most suitable for measuring and dispensing 37 ml of an aqueous solution? So we're talking about volumetric glassware here. We can get rid of some of these answer choices right away. And the ones that we can get rid of are going to be A and C. The reason for that is because A and C are not volumetric glassware. A beaker and an Erlenmeyer flask should only be used for like general getting a sense of the volume. It's not really supposed to be used for getting a really accurate measurement. So the only two answer choices that we're left with are going to be B and D. The problem with B is that it's a burette. And with a burette, you're not really supposed to measure how much liquid you have, because remember, a burette uses an inverted measurement scale. On the top, you have your really low numbers, and at the bottom, you have really high numbers. A burette, the readings, the markings on a burette might look like this. And from this, if you had your burette all the way filled, that would read 0 ml. So you don't really use a burette for measuring a certain amount of liquid. You use it for knowing the change in the liquid level. So if I started all the way at the top and I had a reading of 0 ml, and then afterwards I had a reading of 20 ml, then that means you dispense 20 ml. You look at the change. So burettes really aren't used for measuring like that. Therefore, the only answer that we're left with is D, and D does make sense. D is a graduated cylinder. You have all those markings to help tell you when you have exactly 37 ml. So our answer is D. And that's it for the 2016 USNCO descriptive/laboratory section. I hope you were able to learn something, and I hope to see you later. Thank you.